It was the first half of the 19th century, 1816 to be exact. Michael Chevreul studies in the field of soaps. He was responsible for producing compounds that proved it possible to make chemical changes in various fats without the use of vital force. This opened the doorways to organic chemistry. Along came Frederick Wohlher, and he sat down beside him on the chemistry timeline. He was responsible for discovering urea. Not urine, urea. People then began to say, "Go home, vital force, we don't need you." Then there was William Henry Perkin with his dye, Frederick August Kekulé, and Archibald Scott, whose discovery of chemical structure revolutionized forever the subject of organic chemistry. In short, organic chemistry is the study of carbon-containing compounds. I promise you, these organic chemists don't sit around a fire chanting, "Combustion, combustion." They sit around a Bunsen burner and do that.
Combustion, 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 combustion. Ooh, yeah.
There is much more to an organic chemist. An organic chemist is someone orally fluent and can put their ideas on paper for the world to understand. They often create organic molecules and apply them in everyday life. They do long, tedious calculations with advanced equipment, and the simplest as well. Organic chemists are only a small part of the circle of existence that is chemistry. Geochemists are trained in the way of mineral study to better understand the ever-changing world and how to properly adjust and harness the natural resources around us. Biochemists observe how organisms absorb nutrients and use them, how diseases form and spread, and patterns in basic heredity. There are many more, however. Analytical chemists measure quantities, identify materials, and examine the relationship between matter and energy. Material chemists, medical chemists, and inorganic chemists may all make up the possibilities of careers in chemistry. There are many places you can go to reach the chemist in you. You know Harvard and Yale, but the University of California in Los Angeles, Florida State University, and Rochester's Institute of Technology all offer opportunities for the chemist in you. The most important thing is the research that's been done in the past few years. Sidipta Seal discovered that using fly ash, which is generated in combustions, can clean up oil spills. The ash goes into the oil-water mixture and creates a film on the surface of the water. This film can then be scooped up, almost like kitty litter. The collected oil can be recycled and used again. This can preserve the fuels that can't be replaced. What is your favorite part of organic chemistry?
My favorite part of organic chemistry is actually using it in the lab. Like, I had taken organic chemistry lectures in college, and they were interesting, but when I got into the lab and got to put it to use, and I got to isolate caffeine from tea, and that was pretty cool. That was my favorite part.
Okay. What do you do, or what did you do in your job?
My job recently was I was a research associate. My degree is in molecular biology, and I minored in chemistry, and then I got my master's in genetics. But I worked in a lab where I did epigenetic research and would develop protocols, and so I got to use a lot of my chemistry background, mixing up solutions and developing new protocols, and because that's where I was happiest, was in the lab, playing with chemicals and stuff.
Okay. Where did you go to school?
My undergraduate I did at Brigham Young University, and then I went to graduate school and got my master's at Vanderbilt University.
And what did you have to do to get your degree?
I had to take a lot of classes and do a lot of labs, especially for my master's degree. It really focused on, lab technique and just getting really acquainted with what you do. So I took a lot of lectures, learned a lot of theory, and then spent a lot of time in the lab putting that to work and, learning how to be successful in the lab, because it's not like you see on TV where everything always works out great and you always get the desired result. There's a lot of troubleshooting and things not working, and so it's fun to kind of figure out what went wrong and be a detective and solve it.
Okay. And one more. What made you decide to go into this field?
I took a chemistry class in high school, and we started doing things like titration or getting like an unknown compound, and we had to figure out what it was, and that was just fascinating to me. I loved searching out answers, and I even developed a name for myself. I called myself Captain Labulous because I was a lab superhero, and I kept that name all through high school when I took chemistry labs and then through college. But I just really loved chemistry and biochemistry and thought it was fascinating to figure out how things worked.
Okay. Thank you.